At 12:15 UTC on Tuesday, July 28, 2026, the National Hurricane Center in Miami logged a single line that quietly changed the tone of the entire Atlantic hurricane season. A tropical wave, they wrote, was moving across the Lesser Antilles and into the eastern Caribbean, its axis stretching along 61 to 62 degrees west longitude, running from 8 degrees north all the way up to 19 degrees north. It was pushing westward at roughly 15 to 20 knots. By that same morning, forecasters noted the wave had already begun enhancing showers and isolated thunderstorms across the eastern and southeastern Caribbean, activity expected to persist through Wednesday morning. That is not speculation. That is not a model run. That is an observed real-time entry recorded in the government's own tropical weather discussion. And it is the starting point for everything we are about to walk through. 24 hours later, on Wednesday, July 29th, the same agency issued its formal 7-day tropical weather outlook for the North Atlantic, the Caribbean Sea, and the Gulf. The verdict, in the driest possible bureaucratic language, was this: tropical cyclone formation is not expected during the next 7 days. Two things are true at once here, and understanding how they fit together is the entire story. A real, physically substantial tropical wave has, in fact, entered the Caribbean basin, and it is already producing rain, thunderstorms, and rough seas across island chains that people actually live on. At the same time, the agency responsible for tracking organized tropical cyclones is not currently flagging the system as a near-term hurricane threat. Both of those facts came from the same forecasters, in the same window of days, and neither one cancels out the other. This is what modern hurricane season coverage actually looks like when you strip away the hype. A genuine atmospheric disturbance, tracked with real coordinates and real wind speeds, moving through a basin that is simultaneously being held in check by larger forces working against it. Let's get into what this wave actually is, why it is behaving the way it is, and what plausibly happens from here. To understand what just crossed into the Caribbean, you have to go back to where it was born, because a tropical wave rarely starts as a Caribbean phenomenon at all. Most of the systems that eventually threaten the islands, and sometimes the U.S. mainland, begin their lives thousands of miles away, over the interior of West Africa. As the African monsoon pushes moist air northward each summer, it collides with hot, dry air pushing south from the Sahara. That collision, occurring along a boundary meteorologists call the African easterly jet, creates ripples in the atmosphere, similar in principle to the way wind creates ripples on the surface of a pond. Those ripples are tropical waves, and dozens of them peel off the African coastline every hurricane season, spaced roughly 3 to 5 days apart, each one a pulse of low pressure and enhanced thunderstorm activity riding westward on the prevailing trade winds. Most of these waves never become anything more dramatic than a band of showers. Some fizzle out over the open Atlantic within days. A minority survive the full transit, roughly 3,000 to 4,000 miles, and arrive in the Caribbean or approach the Lesser Antilles, still carrying enough organized convection to be worth watching closely. Based on the discussion issued on July 28th, this particular wave was one of the survivors. Forecasters had already tracked a related disturbance earlier in the discussion sitting further east, near 35 degrees west longitude, spanning from 7 to 16 degrees north, moving at 15 to 20 knots, with widely scattered showers running ahead of it. That eastern wave was trailed by a small, weak, low-pressure area near the monsoon trough, close to 9.5 north and 37.5 west. As that system continued its multi-day march across the open Atlantic, the wave now sitting in the eastern Caribbean had already completed its own crossing days earlier and was the one actively interacting with the islands as of Tuesday morning. So here is the plain sequence of events, stated the way the data actually shows it rather than the way a headline might dramatize it. A wave forms off Africa. It survives an ocean crossing lasting the better part of a week or more. It reaches the Lesser Antilles, the arc of small islands running from the Virgin Islands down through Guadeloupe, Dominica, Martinique, St. Lucia, St. Vincent, and the Grenadines, down to Grenada and Trinidad. It pushes through that island chain and continues into the eastern Caribbean Sea proper, the open water bounded roughly by Puerto Rico and the Virgin Islands to the north, Venezuela, and Colombia to the south, and the wider Caribbean basin opening up to the west, toward Hispaniola, Jamaica, and eventually Central America. That is precisely the geography described in the July 28th discussion, with the waves axis positioned along 61 to 62 west, a longitude band that sits just east of Puerto Rico and squarely within the eastern Caribbean. Now, why does the story not immediately escalate into hurricane warnings, evacuation notices, and the kind of coverage you might expect from a headline like this one? Because a tropical wave and a tropical cyclone are two very different animals, and the gap between them is where almost all of the real uncertainty in this story lives. A tropical wave is fundamentally disorganized. It is a trough of low pressure and a zone of enhanced showers and thunderstorms, but it lacks a closed, organized surface circulation. Wind doesn't spin around a common center. Once a wave does develop that closed circulation, along with sustained thunderstorm activity wrapping around it, it can be classified first as a tropical depression. Then, once winds sustain at least 39 miles per hour, a tropical storm, at which point it earns a name. Only when sustained winds reach 74 miles per hour does it become a hurricane. The wave that entered the Caribbean this week has not organized into any of those categories. It is still, as of the most recent outlook, an open wave, producing showers and storms, but without the tight, self-sustaining engine that defines a genuine cyclone. This is exactly why the National Hurricane Center's 7-day outlook, issued the day after the wave's entry, explicitly stated that tropical cyclone formation is not expected during the next week across the entire Atlantic Basin, the Caribbean, and the Gulf. That is a specific, quantifiable forecast, not a vague reassurance. It means the agency's own model guidance and satellite analysis are not currently showing a credible pathway for this wave, or any other system in the basin, to organize into a depression or storm within that window. 3 environmental factors explain why, and they are worth understanding in detail because they are the actual physics driving this story, not incidental footnotes. The first factor is El Niño. Going into the 2026 hurricane season, forecasters tracked El Niño conditions, consolidating through the late spring and into summer, with a high probability, on the order of 80%, that those conditions would persist through the back half of the year. El Niño describes a warming of sea surface temperatures in the central and eastern tropical Pacific, and while that might sound like a Pacific-only story, its atmospheric fingerprints stretch across the entire globe. In the Atlantic Basin specifically, El Niño tends to strengthen upper-level westerly winds high in the atmosphere over the Caribbean and tropical Atlantic. When those upper winds blow strongly from the west while lower-level trade winds blow from the east, the result is vertical wind shear. And wind shear is, in blunt terms, the natural enemy of a developing tropical system. A young disturbance needs to stack thunderstorms vertically, allowing the whole column to organize around a central axis. Strong shear tilts that column, rips the thunderstorm tops away from the low-level circulation, and prevents the storm from consolidating. El Niño years, historically, tend to produce fewer Atlantic hurricanes overall, even when sea surface temperatures in the tropical Atlantic itself are running warm, because the shear imposed from above chokes off development before it can really begin. The second factor is dust. Every summer, strong winds over the Sahara desert loft enormous plumes of mineral dust into the atmosphere, and those plumes ride the trade winds westward across the Atlantic in a phenomenon known as the Saharan air layer. This dusty air is dry, and it sits in a layer roughly 1 to 3 miles above the surface, right in the altitude range, where a strengthening tropical system needs abundant moisture to fuel its thunderstorms. When a wave tries to organize inside or beneath a thick Saharan air layer, the surrounding dry air gets entrained into the storm circulation, suppressing convection and starving the system of the humidity it needs to intensify. Coverage of the broader Atlantic tropical pattern through the back half of July repeatedly noted a large plume of this Saharan dust sitting across the basin, reinforcing the case for why development, even among multiple simultaneous waves, was being held in check. The third factor is simply wind shear at the basin scale, independent of El Niño's specific contribution, driven by the position of the subtropical ridge, sometimes called the Azores High when it is centered over the eastern Atlantic. Surface analyses through the month showed this ridge exerting a strong influence over the Caribbean, at times producing near gale-force trade winds, particularly off the coast of Colombia and northwest Venezuela, along with rough seas reaching 7 to 10 feet in spots. Strong, low-level trade winds are not inherently hostile to development the way upper-level shear is, but the broader pattern of ridging and troughing across the basin through late July consistently kept the atmosphere from aligning in the way it needs to for genuine intensification. Multiple independent forecast discussions through the week, tracking as many as 4 separate tropical waves scattered across the eastern Atlantic, the area near the Lesser Antilles, and the western Caribbean, each noted the same conclusion. Convection was present, sometimes strong, sometimes only scattered, but organized development looked unlikely given the shear and dry air in place. Put all 3 of those factors together, and you get the paradox at the heart of this story. The Caribbean has genuinely welcomed a real, physically substantial tropical wave this week, one producing measurable rainfall, thunderstorms, and rough water conditions across a wide stretch of islands. And yet, the same atmosphere that allowed this wave to survive its transatlantic crossing is now working against its further organization once it arrived. This is not a contradiction. It is simply how the tropics behave in a summer shaped by El Niño, Saharan dust, and a persistent ridge pattern. Waves can enter the Caribbean fully intact, dump significant rain, and still fail to become anything the public would recognize as a named storm. That said, no cyclone expected is not the same thing as no impact. This is the part of the story that actually affects real people on the ground right now, and it deserves more attention than the average forecast graphic gives it. The July 28th discussion specifically flagged enhanced showers and isolated thunderstorms spreading across the eastern and southeastern Caribbean as a direct consequence of this wave's passage, an effect expected to continue through at least Wednesday morning, and quite plausibly beyond as residual moisture lingers in the wave's wake. For islands like Dominica, Martinique, St. Lucia, St. Vincent, Grenada, and the waters around Trinidad and Tobago, along with the eastern approaches to Puerto Rico and the U.S. and British Virgin Islands, this translates into a very tangible set of hazards. Heavy tropical downpours, even without a named storm attached to them, can produce rapid rainfall rates capable of triggering flash flooding in low-lying areas and urban drainage systems not designed for sudden, intense bursts of rain. In the region's many areas of steep, volcanic terrain, saturated soil combined with heavy rain raises the risk of landslides and mudslides, a hazard that has historically caused more direct harm to island communities than wind ever does during weaker tropical disturbances. Mariners and fishing communities across the eastern Caribbean also need to take this system seriously, regardless of its cyclone status. Surface analyses through the same period described fresh to strong easterly trade winds pulsing across the south central and southeastern Caribbean, with seas building to somewhere in the range of 7 to 10 feet in the most exposed waters, particularly off the coasts of Colombia and Venezuela, and moderate to occasionally rough conditions extending across the wider basin as the wave and the broader ridge pattern interacted. Small craft, in particular, face meaningfully elevated risk in these conditions. And this is precisely the kind of hazard that slips past casual observers who are only listening for the word hurricane. The absence of a named storm does not mean the absence of dangerous seas. There is also an agricultural and infrastructure dimension worth mentioning. Caribbean economies, across nearly every island in this region, remain deeply tied to agriculture, fishing, and tourism, three sectors that are all sensitive to exactly this kind of transient but intense weather. Heavy, sudden rainfall can damage banana and other crop plantings, disrupt fishing fleets that cannot safely put to sea in rough conditions, and create short-term travel disruptions for a tourism industry that depends heavily on predictable, calm weather windows. None of this requires a hurricane to matter economically. A well-organized tropical wave passing directly over an island chain, even without spinning up into a cyclone, is itself a significant weather event for the communities in its path. So what actually comes next? This is where the forecast picture gets genuinely more interesting, because the wave does not simply vanish once its this-week rainfall tapers off. Tropical waves are persistent features. Even after producing their initial burst of showers over the islands, they typically continue drifting westward, carrying at least some of their original moisture and instability with them as they move deeper into the Caribbean basin and eventually toward the Yucatan Peninsula, Central America, or the Gulf. Multiple tropical discussions through the same week describe this pattern explicitly, noting a pair of tropical waves moving in tandem across the central Caribbean, continuing their westward track under the influence of ridging to their north. The National Hurricane Center's forecasters, in the same discussion that logged this wave's Caribbean entry, were simultaneously tracking a separate wave already positioned in the central Atlantic, along the 45 to 46 degree west longitude line, south of about 15 to 17 degrees north, also pushing westward at around 15 knots, meaning additional pulses of tropical energy remain in the pipeline behind this one, each on its own multi-day journey toward the islands. This raises the single most important forward-looking question in the entire story. Does this wave, or one of the waves following behind it, eventually find a more favorable environment further west, perhaps over the warm waters of the Western Caribbean, the Bay of Campeche, or the Gulf, where wind shear patterns can behave very differently than they do over the Eastern Caribbean's typically hostile low-level divergence zone? This matters because the Eastern Caribbean has a well-earned reputation among meteorologists as something of a graveyard for early-season tropical development. Persistent low-level divergence, essentially air spreading outward near the surface rather than converging inward to fuel a storm, tends to suppress organized development in that specific corridor, especially earlier in the season before the deeper Caribbean warms and stabilizes into its late-season configuration. Systems that make it through the Eastern Caribbean intact sometimes find a second chance to organize once they reach the Western Caribbean or push into the Gulf, where wind shear can relax and sea surface temperatures run consistently warm through the peak of the season. None of the current guidance places this specific wave on a confirmed path toward that kind of later stage development, and the 7-day formation outlook explicitly rules out organized cyclone formation through the coming week across the entire basin. But this is exactly why continued monitoring matters more than any single 7-day snapshot. Tropical systems are, by their nature, fluid situations. A wave that looks thoroughly disorganized on a Tuesday can, given the right shift in shear or moisture, begin consolidating rapidly within days, particularly once it clears the more hostile Eastern Caribbean corridor and reaches warmer, less sheared waters further west. This is not a prediction that it will happen. It is an honest acknowledgement that the setup for the following week deserves continued attention rather than a single dismissive headline. It is also worth placing this moment within the broader arc of the 2026 Atlantic hurricane season as a whole. Seasonal outlooks issued earlier in the year called for activity in the range of the long-term average, with independent forecasting groups projecting somewhere around 14 named storms, roughly 7 hurricanes, and about 3 of those reaching major hurricane strength, categories 3 and above, translating to an accumulated cyclone energy index roughly in line with historical norms. Late July sits at an interesting point on the seasonal calendar. Meteorological convention places the peak of Atlantic hurricane activity in the late August through October window, meaning the current stretch is technically still what forecasters sometimes describe as the early or ramp-up phase of the season. Historically, this is precisely the kind of period where multiple tropical waves cross the Atlantic and interact with the Caribbean without producing organized storms, because the atmospheric ingredients, sea surface heat content built up over the full summer, reduced shear, a weaker or absent Saharan air layer, tend to fall into place more completely as the calendar advances deeper into the season. In other words, what is happening this week is not an anomaly. It is a fairly typical late July pattern for a year, running under El Niño's broader influence. Real waves, real rain, real rough seas, but a basin-wide environment still generally unfavorable for turning any of it into a hurricane just yet. That said, generally unfavorable this week is a very different statement from unfavorable for the rest of the season. El Niño's influence on Atlantic hurricane activity, while real and well documented, does not create a hard ceiling that prevents every storm from forming. It shifts the odds, sometimes substantially, but strong, warm sea surface temperatures across the tropical Atlantic, which several outlooks this year specifically flagged as running above normal, particularly along the corridor sometimes called Hurricane Alley, stretching from West Africa toward Central America, still provide meaningful fuel for any system that does manage to find a shear-free pocket in which to organize. This is the tension that defines almost every El Niño hurricane season. An ocean surface primed with energy, sitting beneath an atmosphere that is, for now, working to keep a lid on that energy. Whether that lid holds through August, September, and October, the traditional heart of the season, remains an open question that this single wave cannot answer on its own. For residents across the Lesser Antilles, the Virgin Islands, Puerto Rico, and the wider Caribbean, the practical takeaway from this week's developments is straightforward and does not require panic. It requires attentiveness. A wave producing enhanced showers, isolated thunderstorms, and locally heavy rainfall is worth treating with the same seriousness any resident of a flood-prone or landslide-prone area would apply to any significant rain event, hurricane label or not. That means staying aware of local Weather Service guidance rather than relying solely on whether a system has earned a name. It means understanding that flash flood and landslide risk from a disorganized tropical wave can, in specific and limited areas, rival the impacts of a weak-named storm, even without sustained winds anywhere close to tropical storm strength. It means mariners and fishing operations paying attention to marine forecasts describing elevated seas and gusty trade winds, independent of the cyclone development conversation entirely. And for the broader public, simply trying to understand the state of the season, it means recognizing that no cyclone formation expected in the next 7 days is a specific, technical, and currently accurate statement, not a guarantee that nothing more will happen as additional waves continue queuing up behind this one across the Atlantic. It helps to understand just how normal it is for the Caribbean to see this many waves stacked up in a single week, because the number itself often gets treated as alarming when it is actually closer to routine. Independent tropical trackers, following the same stretch of days, counted as many as 4 distinct tropical waves scattered across the wider basin simultaneously. One well out in the eastern Atlantic near the Cabo Verde Islands, wrapped in that same dry Saharan air. One positioned east of the Lesser Antilles, still over open water. One sitting almost directly on top of the Lesser Antilles and pushing into the waters just north of Venezuela, showing little to no organized convection. And one already inside the Western Caribbean carrying noticeably stronger shower activity. None of those 4 had been designated by the National Hurricane Center as a formal tropical invest, the informal shorthand for a system judged worth close monitoring for potential development. That absence of a designation is itself informative. It tells you the agency's own analysts, looking at the same satellite loops, the same wind shear analyses, and the same moisture fields available to any outside forecaster, did not see enough organization in any of those 4 waves to elevate them above routine tracking status. A basin can be simultaneously busy and quiet in exactly this way, filled with real disturbances that are for now more meteorological noise than genuine threat. It is also worth walking through, in slightly more technical terms, how forecasters actually assign the numeric formation odds that show up in these outlooks, because the phrase low 30% or not expected can otherwise sound like a guess dressed up in official language. Forecasters weigh a handful of measurable ingredients against each other. Sea surface temperature beneath the disturbance needs to sit above roughly 80 degrees Fahrenheit to depths of at least 50 meters, providing the latent heat engine a storm draws on as warm water evaporates and condenses higher in the atmosphere, releasing energy in the process. Mid-level humidity needs to be high enough that dry air entrainment, the same mechanism by which Saharan dust suppresses development, does not choke off the thunderstorm activity trying to organize around the wave's axis. Vertical wind shear, the difference in wind speed and direction between the surface and the upper atmosphere, needs to stay below a threshold, often cited loosely around 20 knots, beyond which a storm's vertical structure gets torn apart faster than it can rebuild. And finally, the wave itself needs a favorable steering pattern, typically weak upper-level ridging directly overhead, allowing rising air to vent outward rather than getting capped. Forecasters run this checklist against a suite of computer models, chiefly the American GFS model and the European ECMWF model, along with a range of ensemble members that vary initial conditions slightly to produce a spread of plausible outcomes rather than one deterministic answer. When the majority of ensemble members agree that shear will remain high and dry air will persist, as they did through this stretch of days, the formation percentage gets reported as low, and the language in the outlook shifts toward monitoring rather than warning. This is also a good moment to walk island by island through what this kind of wave passage typically means on the ground, because impacts are rarely uniform across a chain that spans more than 1,000 miles from the Virgin Islands down to Trinidad. In the northern Lesser Antilles, islands like Antigua, Guadeloupe, and Dominica tend to see the heaviest, most convective downpours first, simply because they are the first landmasses a westward-moving wave axis encounters, often with the most vigorous thunderstorm cells embedded directly along the leading edge. Dominica and St. Lucia's mountainous volcanic terrain then converts that heavy rain into a landslide and flash flood concern almost immediately, since steep slopes with thin soil layers saturate quickly and lose cohesion. Farther south, Martinique, St. Vincent, and the Grenadines and Grenada typically see the wave's trailing moisture combine with the region's own daily sea breeze-driven thunderstorm cycle, which can actually prolong the rain threat by a day or two after the wave's leading edge has already moved on. Trinidad and Tobago, sitting closest to the South American coast, often experience the wave's passage as more of a wind and sea state event than a rainfall event, given their position relative to the strongest trade wind fetch described in the same marine forecasts. And to the north, Puerto Rico and the U.S. and British Virgin Islands, positioned right at the edge of the wave's axis near 61 to 62 west, can expect the kind of scattered, sometimes locally intense showers typical of a wave's outer rain bands, without necessarily seeing the sustained, organized rainfall totals of islands sitting more directly beneath the wave's core. Shipping and regional commerce add another practical layer worth mentioning, since the Caribbean remains one of the busiest maritime corridors in the world, carrying container traffic, cruise itineraries, and regional inter-island ferry routes through exactly the waters this wave has been crossing. Rough seas in the 7 to 10 foot range, of the kind described across the South Central Caribbean and off the Colombian and Venezuelan coasts, are enough to force smaller vessels and inter-island ferries to delay departures or adjust routing, even though they pose no threat whatsoever to large container ships or cruise vessels built for open ocean conditions. Regional port authorities and shipping coordinators typically monitor exactly this kind of marine forecast language: gale force pulses, elevated swell, near gale conditions off specific coastal stretches, far more closely than they monitor the tropical cyclone formation outlook itself, because for their purposes, a strong wave and a weak tropical storm can produce comparable sea states, even though only one of them would ever appear on a hurricane tracking map. Zooming out one more level, this week's developments also offer a useful lesson in how to actually read tropical weather information rather than simply reacting to whichever headline sounds the most alarming. The raw data here told a clear story with no need for embellishment. A specific wave, tracked at a specific longitude, moving at a specific speed, entered a specific body of water on a specific date, and produced a specific documented set of impacts, enhanced showers and thunderstorms across a defined stretch of islands. Separately, and just as specifically, the agency responsible for tracking organized cyclones stated that none are expected to form across the entire basin within the coming week. Both statements are precise, both are grounded in the same underlying observational and model data, and both remain true simultaneously. The real skill in following hurricane season coverage, especially in years shaped by competing influences like El Niño's shear and a warm underlying ocean, is holding both of those truths at once rather than collapsing the story into either false alarm or false reassurance. Looking ahead, the elements to watch over the coming days are reasonably well defined. First is the fate of this specific wave as it continues its westward track deeper into the Caribbean, potentially toward the Western Caribbean, the Yucatan Channel, or ultimately the Gulf, where the wind shear and moisture environment can differ meaningfully from what it encountered crossing the Lesser Antilles. Second is the wave sitting further back in the central Atlantic, positioned in that 45 to 46 degree west corridor as of this week, following a broadly similar track and timeline, meaning the same questions about Eastern Caribbean shear and Saharan dust will apply to it in turn once it arrives, likely within another several days to a week. Third, and more broadly, is the underlying seasonal question of how long El Niño's suppressive influence over Atlantic development holds as the calendar pushes toward the historically more favorable, higher heat content conditions of August and September. None of these are answerable with certainty today, and any credible forecast source will tell you the same thing. This is a fluid, evolving pattern worth continued attention, not a single resolved outcome. To bring this back to where we started, the headline claim holds up entirely under scrutiny. A powerful tropical wave, well-defined enough to be explicitly logged by name and coordinate in the National Hurricane Center's own tropical weather discussion, did enter the Caribbean this week, crossing the Lesser Antilles and pushing into the Eastern Caribbean Sea along an axis near 61 to 62 degrees west, enhancing showers and thunderstorms across the eastern and southeastern islands as it went. What comes next, based on everything currently available in the official record, is a period of continued monitoring rather than imminent alarm. No tropical cyclone formation is expected across the Atlantic, Caribbean, or Gulf over the coming week, a conclusion tied directly to a documented pattern of El Niño-enhanced wind shear, a persistent layer of dry Saharan dust, and a broader ridging pattern that has kept multiple simultaneous tropical waves from organizing throughout the back half of July. At the same time, real, tangible impacts, heavy rain, flash flood and landslide risk in vulnerable terrain, and rough seas across exposed Caribbean waters are already unfolding on the ground and deserve the same practical attention any significant rain event would receive, independent of whether this particular wave ever earns a name. That is the honest, data-grounded state of play as this wave continues its journey westward, and it is exactly the kind of nuanced, evolving situation that the rest of this year's hurricane season, still in its earlier and comparatively quieter phase, will likely keep producing again and again as additional waves continue their long crossing from the African coast toward the same warm, watchful waters of the Caribbean.